Hi everyone, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we are going to see the topic Clipper using operational amplifier from the subject linear integrated circuits. Okay. Before seeing the topic, we can see the outline. Why Clipper circuits are used, what are the types of Clipper, working of each type of Clippers, input and output waveforms, and their applications, and finally the assessment. Okay. So before going to the topic, we need to see what is the purpose of Clipper. Clipper is an electronic circuit that produces the output by removing part of the input signal above or below the reference value. Okay. So based on the particular reference value, we are adjusting or removing some part of the input signal. So that is the thing happened with the help of Clipper. So this by doing this activity, the main advantage of using is nothing but eliminating the unwanted noises and unwanted amplitude of an given input AC signal. Mostly, preferably AC signals are utilized here. So based on the need, the given input signal will be clipped and the accurate output will be obtained with the help of the Clipper circuit. So that is the main purpose of using Clippers. So these such sort of Clippers are utilized in many digital communication system and signal processing application and so on. Okay, so here Clipper is an electronic circuit that produces an output by removing a part of the input above or below a reference value. Okay, here coming to the types, we are having under the classification series Clippers, we are having two types, mainly positive Clippers and negative Clippers. Okay, we can see the circuit diagram of positive Clipper here. So in which IC741 operational amplifier is utilized to give the input signal through the positive input terminal VI, and then D1 is the diode. It's nothing but the precision diode, which is utilized in order to do this clipping operation. So these precision diodes, we need to see a small recall of this precision diodes, which is differ from normal diodes. The functioning of precision diodes starting from even before the cut-in voltage. So that is the main advantage of the using of precision diodes, which improves the accuracy and efficiency of the circuit wherever these precision diodes are utilized. So that is the purpose of these precision diodes. And then we are connecting the reference voltage with the negative input terminal of the operational amplifier. So here in this circuit, V reference can be chosen by varying the value of the reference, varying the value of the resistor R2. Here the positive Clipper clips only the positive portion of the input signal. So we can see how. When the condition, so if you are seeing V reference is given to the negative terminal, and here if you are seeing in the positive terminal we are giving the VI value. So until otherwise VI is less than V reference, the diode D1 starts conducting. So this is the condition. So when VI is less than V reference, diode D1 starts conducting, and thus the circuit acts as the voltage follower circuit. So whatever may be the input, that will be produced as the output of the Clipper circuit. So when the condition VI goes greater than V reference, the diode D1 will becomes off. So there will be no output. So this is the case for the positive Clipper. So we can see this with an input and output waveform. So here we are having input output waveforms based on the reference voltage. First one showing the above diagram showing the positive reference voltage, and second one right hand side above diagram shows the negative reference voltages. So first we are concentrating on positive reference voltage. So if you are seeing the positive reference voltage, so that is considered as plus 1 volt. So that is slightly greater than 0. So if you are seeing the input voltage, we are taking a sine wave. We are taking a sine wave as the input voltage, and then if the sine wave that is going above the value 1 volt, so that will be clipped off as per the condition Vi greater than V reference. At that condition, diode will be in off condition. So if the diode is in off condition, no output will be produced from the clipper circuit. So that is the case here. So that is why it is mentioned D1 is off. Similarly, when V reference is negative, that is minus 1 volt. So in such case, so the same thing, when Vi is less than V reference, the output will be produced, and when Vi is start moving greater than V reference, the output will be cutted off because of the diode D1 is in off condition. So in both diagrams we are clear that based on the reference voltage, how the input voltage is shaped or altered based on the need. Similarly, here we are seeing the negative clipper circuit. So here in this circuit, if you see the input is connected in the same manner, that is Vi and V reference, both inputs are connected in same manner, but only difference is the D1 diode is connected in an opposite direction. So that is the case makes this negative clipper circuit. So this negative clipper circuit clips only the negative portion of the input signal. So with the same similar type of operation, we are having the condition when Vi is greater than V reference. For negative clipper, similar to the positive clipper, when Vi is greater than V reference, diode D1 will conduct here, and when Vi goes less than V reference, we need to note down here. So it is just opposite to the condition what we followed in the positive clipper. In positive clipper, when Vi is less than V reference, diode will conduct. But here, when Vi is greater than V reference only, diode will conduct. And when Vi goes less than V reference, diode will be off condition, no output will be obtained. So we can see the output waveforms based on the positive V reference and negative V reference. So here in the first diagram above left top, the negative V reference minus 1 volt is taken. So whenever Vi is greater than V reference, so the output is obtained, and whenever Vi is goes less than V reference, the output is clipped off. So that is negative clipper circuit's function. In the same manner, if you are taking the positive V reference value, that is plus 1 volt, so if Vi is greater than 1 volt, the output is obtained, and when Vi is goes less than V reference, the output will be 0 since D1 is in off condition. So this is the case for both types of clipper circuit. So such circuits can be utilized in various applications that are listed here. Waveform shaping application, useful in applications where specific waveform characteristics are required, such as digital computers or communication systems. Waveform shaping, that is, we can rearrange the amplitude and we can move further. So that is the main application here. And then voltage limiting. So we can protect sensitive electronic components from damage caused by voltage surges or overdriving. And then noise reduction, to use it to remove noise spikes or pulses that are above or below a certain threshold value. And further, these clipper circuits are utilized in radio receivers to remove noise pulses and radar systems to limit signal voltages. So with a vast applications, these clipper circuits are a must-needed circuit which can be designed efficiently with the help of the precision diodes and operational amplifier IC741. So we can summarize. We have started with what is the need of clipper circuit, and we have started seeing about the classification of the clipper circuit as positive and negative. So what is the working of the positive clipper circuit, and what is the input output waveforms based on the V reference value, and what is the we have started see about the negative clipper circuit and its operation working, and then finally input output waveform of the negative clipper circuit was seen, and finally the applications, what are the various real-time applications we are using this clipper circuit, that is seen here. And then coming to the assessment part, the clipping level in an op amp is determined by reference voltage. So that is the right answer. And in a positive clipper, the diode conducts when V in is equal to V reference. So that is the correct answer. And what happens if the input voltage is higher than reference voltage is a positive clipper? Output voltage will become equal to the reference voltage. So these are some assessment questions based on the topic clipper circuit. So thank you for joining this video. Once again, we can meet in the next video. Thank you all.